All right, we're live. Check it out. Llama 3.1 405B has officially released. That's right. You can download this massive model and start using it today. So the problem is that this model is so big that you may not be able to use it on all your devices. So just as a heads up, tonight we're going to do a live stream with Alex Chima, and he's the founder of XL Labs. And it's basically, we're going to be firing up all this inference with all these devices. Apparently, you only need a couple of MacBooks and maybe a Mac Studio to load this entire model up. So there's a bunch of stuff that's going to be going on. It's going to be so epic. It's going to be just like this crazy video here with everyone basically trying to load this model up right now. So I think half the internet right now is trying to download this really gigantic model. And so this is the effect that we're going to have at 4:20 p.m. Pacific Standard Time. So I should probably do that. Can I still edit the tweet? Oh, no, I can't. Okay, I should do Pacific Standard Time. So PST, my friends, 4:20 PST. Let's go. So we're in Pacific Standard Time, and it's somewhere here in the Bay Area. We're going to go. I'm actually going to bring my camera equipment and stuff. So I'm going to film him getting the stuff set up using XL Labs. So for those who don't know, Alex was the winner of one of these hackathons. And as a winner of the hackathon, he was able to hook up a lot of these computers and do distributed inference with I think the tiny box and stuff. And what we also have here are some other folks in the community who've been able to use XL Labs to basically connect 23 Mac Minis to give a ton of inference here available. And so the way that this XO cluster works from XO Labs is it's actually pretty simple. So I can probably walk you through getting that set up. So for those who are joining in today, Llama 3.1 has officially announced, and you can actually go download this right now. So you can either try it on Meta or just download the model. So if you are nerding out like me, you're probably wanting to download the model right now. And I think I'm going to go ahead and get that going in just a little bit. I just want to let some folks know who are just getting on the stream right now that we have this going on, and then that we're going to be doing a live stream today at 4:20. So tune in live 4:20 p.m. Pacific Standard Time, and I'm basically going to be meeting up with Alex at his place that he's currently crashing right now with a bunch of machines. And for those who are wondering, like how many machines and stuff do you need to actually run inference on this thing? Apparently, all you need is just a couple of, let's see, I think he has a post here for how much you need to run. Basically, all you need are 2 MacBooks and like 1 Mac Studio to run. So you basically need like 110 flops here to do this type of distributed inference. And his software basically lets you do that quite easily. So just a heads up, and here's XO Labs. And so their GitHub is here on their link tree. So if we just go to their GitHub will show us the project here. Let me just kind of move my head aside. And then within here, the setup is actually fairly straightforward. So we're going to be doing some of this setup here. I think I've already set up the environment, but we should be able to kind of get this going here. So CD workspace. Yeah, I already have XO set up. I've cloned the repo, CD XO here. Just kind of put this up here. And let's see. Conda. Yeah, and I've already set up my Conda environment. So for those who aren't familiar, you can set up a Conda environment so that you can set up with Python 3.12. And then from there, you should be able to basically start to run this thing. So once you do the pip install, then you should be able to just kind of do Python 3 main py. And boop, we should be able to get this thing up and running here. So yeah, this just tells me the computer that I have and how many flops I have available. So if I add another computer to my thing, I should be able to see 2 of them, and you'll actually see them start talking to each other. And so yeah, this is kind of what it looks like. And then if we go to this like URL locally here for me, I should be able to see like a little chat window load up. And then so we should load up this here. I can kind of keep this in the background. This is like a little thing called Tiny Chat. So if I get to say, how are you? Should be able to kind of load up some stuff. And this should be able to, what is it doing? Yeah, this is basically streaming in this response. What is new? And so this is the platform that we're going to use basically to, first we have to download the Llama model. And then once we download the model, and have that available, I need to go put that on the different machines and then basically run this script here from XL Labs, which is going to basically connect this whole cluster for us. So to do the downloading of the model, all you have to go to is go to, let's see right now, just go to llama.meta.com. And so once you go here, you could just say download models and then fill in your information here at the top. And then it's going to ask you, do you want to, yes, all of the things. And then basically once you start to download the models, I think it's going to say, let's see if I go download models. Okay. Once you fill out the information, it should then take you to a next step where there's a GitHub repo that you would clone and then run a download script. And it's going to give you a unique URL that you can use to download for the day. So let's see. I think I started this setup on another screen. So let me see if I could find that. Actually, and then I should be able to get the notes and stuff going as well. Notes. So yeah, let me get that sorted out here for you. So for those who are just tuning in, basically Meta has just released their new, it's called officially Llama 3.1 405B. And it's their largest openly available model. And basically it's 128K context length and it has improved reasoning and like coding capabilities. Also has like upgraded multilingual models as well for the 8B and the 7B model, 70B model. So that's for the smaller models if you want to run those. So you should be able to kind of get that up and running today, actually, which is pretty awesome. And what we're doing right now is basically trying to see if we can download the Llama stuff. So they have a GitHub, which I should be able to load up here. Here, perfect. So this is their Llama models public. So if you just search Meta Llama models, you should be able to see this repo here from Meta. And then this is going to be the thing that we use to download the models here. So it's going to take us through, ensure you have wget and MD5 sum installed. And I'm not sure, do I have this project in my workspace? Let's see. Llama. I think it's called Llama models. Llama models. ls grab llama. I don't. Okay, let's clone it. Git clone. Cool. Oops. I should probably spell clone correctly. Let me put the little guy here. Okay. All right. And I'll move this down below. Make this a little bit bigger so people can see. So git clone this. All right. cd llama. Whoops. Models.git. Whoops. Cool. And then I think the script that they want us to run is in here. Sure. I don't even know if I have the right con to activate. Let's see. All right. So .download/sh ./download-sh. Where is that file? Go to file. Oh, it's in Llama 3.1. Okay. Llama. Where are you? CD models. Llama 3_1. Whoops. Perfect. Okay. So let's just see what's in here. Yep. Download.sh. Permission denied. Why is it again? Let's see. I thought it would give us the information to run the script. Download. I'm just going to see what the permissions are. chmod +x download.sh. And then see if we can now run the script. Okay, cool. Okay. So what Llama does is after you sign up for Llama via the download Llama area here and fill out your information and hit next, they're going to give you a specific URL in your email. And so what you do with that URL is then when you go to this script here, you would then just enter the URL from the email, and that's going to basically allow it to download. So let me go ahead and see if I can do that on a different screen here since I have it loaded up. And so let me copy and paste that here. Great. Wow. Okay. So let me kind of minimize this here. Boop. Okay. So once I've put that in, basically I now get this model list of which model do I want to download. So choose the model to download. All of them? I want to do the 405B one. So I just copy and paste this one, I think, right? I don't know. Let's see. Okay. Oh, then it's kind of walking me through models available for download are these ones here. So I want the, okay, so FP8, MP8, MP16 instruct. So I need to jog my memory again because the 8 bits are the quantization. The instruct ones are there's like a base model, which you can use to then fine tune and do stuff with it. And I think the instruct one is the one that's basically you would use like for a chatbot, which has kind of been tuned for that. And then MP, FP, I don't know all these names. So let me just go ahead and use Claude for this because that's why we have AI. So what do the names mean? Like FP or MP, etc. And what is the difference between that and the instruct ones? Cool. So let's just put that in here. And so what I'm using is Claude, of course, Jean-Claude Van Damme. Okay. So, oh yeah, full precision, mixed precision. Great. This is great. This is what AI was made for. I'm going to make myself a little bit smaller so y'all can see what's going on. So turn off my large overlay and let me just put the smaller one up so that y'all can see here a little bit what's going on. Okay. So right now what we have is the base main is Meta, Llama 3. And then let me move myself maybe over here. Okay. Yeah. Okay. And then what we have is FP would be the full precision. So that's 32-bit float. And then MP would be mixed precision. And then fully B float 16. So 16-bit floating point format. And the numeric suffix 8 or 16 likely indicates the bit width that's used for quantization for specific implementation of mixed precision. And then instruct design designation is the name that are fine-tuned versions optimized for the following instruction performance tasks, as opposed to like the base models, which are just for general language modeling. So like the key differences here are between like the instruction tune versus the base models. So the instruct are optimized for task completion and following instructions. And so without the instruct are basically base versions. So it's suited for general language modeling tasks. Okay, so if we want to run like the chatbot experience, we would probably use the instruct ones. So you would just say, hey, can you give me X, Y, Z? And that's the one that's going to basically tell you like, oh yeah, this is the thing that you should be paying attention to. And then like if you want to use your, like do your own fine tuning, what I would just do is probably not use that one, use like the other one. So we probably want to play around with the instruct ones. So let me go ahead and see if I can kind of get that going here. Let's get some beats going. So another interesting thing is that how do you know how much RAM you have available to run for your given device? So right now, the problem is if I download the full like everything model, like at MP16, right? That mixed or like, like at the highest bit rate, I'll probably need a lot of RAM available. So like, let's just see. Right now I have a 64 gig machine, and then let's just select the quantization level of FP floating point 16, right? So with this type of system, the biggest model that I can run on my computer right now with FP16 is 30 billion parameters, basically. So that's gonna be, I mean, that's actually not that much, because we're running a 405 billion model, and that's kind of what people were like complaining online. Like, okay, now you have this big model, what are you gonna do with all this stuff? And so what Exo Labs is gonna do is be like, yo, we're gonna figure this out, and you can connect a whole bunch of Macs. Apparently, you only need like 2 MacBooks, and all you need apparently is just 2 MacBooks and like 1 Mac Studio to run the whole model. And so if we select FP16 right now to download, it may not work for our use case. And if we just do the 8-bit model, that gets us 60 billion parameters. This is on a 64 gigabyte RAM machine. So if I even do 4-bit, I could run a 121 billion parameter model. So that's kind of the math here. But if I have, let's see, if I have 2 machines, right, 128, I'll maybe be able to run 250 and 256 gigs. I'll be able to run it at a 4-bit quantization. And if I do like an 8-bit, maybe. So it's going to require a lot of RAM and stuff. And I'm not sure exactly what the techniques are, but we're going to be talking with Alex at 4:20 p.m. Pacific Standard Time to basically go over getting the model set up using his specific Exo Labs project. And so with his Exo Labs projects, it should be able to allow us to do some distributed inference. And that distributed inference will allow us to run like a couple machines, like 2 MacBooks and like a Mac Studio, load the model up and be able to chat with it using that. So what's really nice is that there are folks who are who have like computers either at a lab or at work, or just have them lying around the house. So that should be able to kind of get us going there. So yeah, that's Alex, and he's the winner of Hackathon. And is doing really, really cool stuff with, edge AI things, and has also studied physics at Oxford. So, I mean, lots of really cool stuff. So if you haven't had a chance, go ahead and go follow him at the handle AC_crypto. He's going to be doing the thing there. And so we're going to be playing around with Exo Labs. And so Exo Labs has a GitHub repo. So you can download this right now and get this set up on your machine while you are also downloading the Llama model. So, and just keep in mind, to run the model, it's going to take a boatload of RAM. And so tonight at 4:20, we're going to get this going. So this is going to be really, really cool. And if we get this going, I mean, he's definitely working on it right now. So I'm just curious. I'm just going to download like this one for now. I mean, might as well download the biggest one and then kind of work my way down. So enter the list of models to download without spaces, or press enter for all. Let's go. Let's just get all of them right now. I'm just going to download all of the models. Who's ready to do this? I might break my internet connection, but oh well. Okay, 750 gigs of disk storage space, and necessitating 2 nodes of MP16 for inferencing. Enter yes to continue. Yes, my body is ready. Yo, we need some mood music for this. Should I hit yes? Should I hit no? Yeah. Oh, I haven't even been paying attention to the comments. So yeah, let's go ahead and do this. Thanks for doing this. Yes. Oh, Dedrick. Yes, definitely appreciate that. I'm ready to see this, Ray. You are the man. Hey, I am not the man, actually. Alex is the one that's really going through the effort right now to like actually hack away and get this going right now. So he's doing the thing, and he's basically getting it like set up so that by 4:20 we'll be blazing. Blaze it up. All right. I was wondering how you're fitting this onto a normal computer. Yeah, that's right. So yeah, do it. Fill up your computer. Let's go. All right, William. Billy. Oh, for those who don't know, we're going to go ahead. Oops. My computer does not break. Okay, so I'm going to go ahead and hit yes because Billy says so. And so let's go. Okay, full send. We're downloading the model right now with the dramatic music too, ladies and gentlemen. All right, it's happening. We are making history together. Let's go. So for those who don't know, Billy, while this is downloading in the background, Billy Willie, I think it goes by William Babrinskas. Let's get here. Cool. Has released an app, and Billy is actually kind of known as the Andre Carpathy of Swift. He's basically wrote his own neural network from scratch using Swift, which is absolutely bonkers. If this is before like AI was cool, and he's just absolutely obsessed and is a really, really like top tier engineer, and really takes the time to figure out these types of problems. And is just a very curious person, and has dropped his own app called Huddle. And this app is actually featured now on Product Hunt. So if you're on Product Hunt, I would definitely, like, since he's a friend of the show, I want to pimp his stuff and go ahead and give him an upvote, because today I think he's battling in the Product Hunt sphere. It's currently battling a bunch of, like, see the launches today. I think it's Meta as well. So like it's a pretty big list of people that are announcing today. So there's already people who appear, like the big guys usually release on Tuesday. So we're at this level here. And he's like, anything that can help support him would be really cool. But so what Huddle does is basically it's like a secure way of like having all your stuff locally on device. So like think social media, but just like, just keeping it all on device. That would be so, easier for you to kind of stay in touch with friends, but not like actually have it out there. It's literally just peer to peer. So you're just sending it from one device to the other. So when I meet up with you, I can share any stories I want or anything like that. So I have the app, downloaded it. It's on the App Store. It's a really cool app if you haven't had a chance to check out. So definitely appreciate Billy showing the love as well, and kind of supporting us as well here for this endeavor. So while we're doing that, we're just kind of catching up on the Llama download. It's going to take us, I don't know how long it's going to say. Is it 18 minutes to download? Let's go. Oh, 750 gigabytes in 15 minutes. What a time to be alive. Yeah. So that basically what we're doing right now is we're connecting to download like all of the things of the internet. I don't know we're probably going to flood the entire network with so much stuff. So it's going to be amazing. So yeah, we're basically trying to download this entire Meta Llama 3.1 model onto our device. And the way we're doing it is just going to llama.meta.com. And from there, basically, you should be able to hit the download models. And then from the download models, this area is basically where you're able to download the models for yourself. And then to do that, you'll actually need to go to their actual GitHub repo under Llama models, and then use the download.sh script. And the download.sh script is currently tucked away into models, Llama 3.1, because that's the model that we're downloading, and then use the download.sh script. And then when you run the script, that script is actually going to ask you to insert that link that you got from the email. And that's going to allow that basically, I think, what does it have in there? Some parameters that have some headers for the download request and like an ID that basically will give you access to downloading the model. So then at 4:20, since the model is so beefy, we're going to have a live event that's going to be going down today at 4:20 at Alex's current spot that he's crashing right now here in the Bay Area. So I'm going to bring over all my live streaming equipment. This is literally going to be like so much hype, exactly like this video. We're just going to have tons of people. We're going to have like all these crazy weights all over. And then this is Alex just literally going to be on that machine, just like putting the team on his back and like just doing these like lifts like no one's business. It's going to be so insanely fire. So that stay tuned for that. That's going to be, get your work done, do what you need to do, and then come back for the show because I think it's going to be really awesome. So Billy says for his app Huddle, the database is on the phone fully. And yeah, thanks for the shout out, of course. So one of my favorites, kind of reading the comment here. One of my favorite ways of testing a model is to ask it to simulate a debate between two experts. Insert a topic, maybe choose a crazy, ridiculous topic to have fun and see how it does. Yeah, I think that's a really good idea. I think another one that people had asked for was like, see if it knows the difference between giving it model numbers, which one is higher, or something like that. It's like, what's 9.1 minus 1, 9.1 or something like that. I forget what it was, but it was kind of funny. But yeah, I agree. I think this is like going to be some really cool ways to see if we can ask it and then just see what the performance is like with these models. So yeah, that's going to be really cool just coming up today. And so as of right now, what we're doing, and hopefully my stream isn't lagging, but we're downloading the entire Llama 3.1, just all of the models, all of the 405s, like everything. And for those who don't know, it's going to give you some options. And so what we were going through today right now is like, hey, which models you want to download? And for me, since I'm kind of still new to this stuff and still trying to understand this space a lot better, I thought, okay, so let me just put this. This is a perfect question to ask Claude and kind of help me break down what the differences are. Yes, I never thought I'd see Blade Runner type questions. Yes, yeah, definitely. So what I'm doing with this here is basically it tells us like the precision indicators. So FP, if you see FP, it's going to say full precision. Then MP is mixed precision, and then fully B float 16 is FB. So that's fully B float. And so in the model choices that we got, I think were MP 16. So that's the mixed precision, and then mixed precision 8, and then FB 8, which was also fully like the full precision, but just 8 bits. And then these are mixed precision down here, and then the full precision 8. So and then there's a difference also that we had asked about, like what's an instruction model and like what's the difference between the two. So the instruction ones are the ones that you probably typically see like in a chat like interface, where you ask it for instructions and performing tasks, and it tends to be really good as for general language modeling. But if for those who wanted to do fine tuning, you probably wouldn't use that. You would probably use the base model, which is the one that's basically not listed here. That says it's like all the ones that don't say instruct are the base models, and that's what people use to like tune their coding one or to tune it for like specific tasks you want to do. So for future reference, that's kind of what you have here. And FYI, as we're kind of going through to download these models, and I have an app called LLM Calc. So LLM Calc. Let's see if I can put this in the stream here, so that you can check this out. So this is kind of what I was using to, let me edit this text here. So it's like LLM Calc. Oops. -rayfernando.ai. Okay, here we go. Cool. So this is the link that I was using for, I made this little, actually this is open source, so you should be able to get this on my GitHub. Let's see, people are talking about it. Does it even show up? No, it doesn't show up on my, okay. Well, it should show up on GitHub somewhere. And actually, you know what I should do is put the GitHub link at the bottom so people can contribute, because it's open source. I open source this, LLM-calc. And then you should be able to basically from here, just download and figure out like how much RAM you need for whatever model size. So like if you get the 8-bit model and you have basically 60, I have a 64 gig RAM in my machine, it tells me that I should be able to kind of run with 60 billion parameters. So that just tells you where you are in the scope of things. But what's cool about Alex's thing with XO Labs is once you start hooking up the computers with the XO Labs, it's going to tell you how many flops you have to use. And so this is going to be super handy for understanding like where and how many tokens per second. So here's kind of a little bit of preview of his setup that he has going on right now for his app stuff. So we're going to be taking a look at that today at 4:20. So it's going to look basically, I'm going to bring my live stream setup over to his place, and we're just going to go crazy. We're going to see like how many machines can we get running. You know, I'm going to bring my 64 gig Mac. I'm going to try to see if I can, grab some other machines as well and just run this model. So completely open source. If you haven't had a chance to check out EXO, go ahead and do that and get it cracking. So this is going to be the place to do. So remember to download MetaLlama, and I'm still downloading all of the things right now. And so this is going to take me like 11 more minutes. So how much total RAM do I need for this? That's a really good question. So I think at least you need 400. So if you had 512 at the like 16-bit quantization rate, like floating point 16, sheesh, bro. That's absolute bonkers. Okay, so dang. So hold on. If you do, let's see, 512, maybe add like 760. If you do 768, let's see. No way. Oh my God, bro. 768 and then plus like another 128 gig. You have like 896. 896. Oh. Wow. So if I just throw 728 plus the 64 is like 832. Oh my God, bro. Like 800 gigs of RAM? No, 832. Sheesh, bro. Yo. Oh my gosh. Yeah. This thing. Oh wow. Wow. Okay, so yeah, this is massive. This is beefy. This is beefy AF, man. Like this is sheesh, bro. So you sort of basically, this is running it like on one machine and assuming these types of things. And so what I want to do when I'm going to meet up with Alex today, I kind of want to ask him about this. It's like, how are we going to get this entire thing running using XO Labs? Because XO Labs has some sauce in here, and they're, I don't know exactly what, but let's just kind of read through this and see if we can kind of figure it out, Brad, because I think this is a really good question. And then people are wanting to know this right now. But setting up XO Labs is really fast. You just basically clone the repo, install it, and then just basically run the Python script here, and you're up and running. And so every machine that you just run this script on will then start to find each other on the network, and then should be able to load up. So, but yeah, we're gonna go over it more with Alex, and he's gonna should be able to kind of give us a breakdown of the details. But yeah, forget expensive NVIDIA GPUs. Unify your existing devices into one powerful GPU. Yeah, so that's pretty cool. It's experimental, obviously. So it optimally splits up models based on the current network topology, enables you to run larger models. So there's an automatic network discovery. And then, and so it supports partitioning strategies to split up the models. So the default partitioning strategy is a ring memory weighted partitioning. So this runs inference on a ring where each number runs a model layers proportional to the memory of the device. Okay, so this looks like it does some type of calculation to split out the memory and saying, okay, this is how much memory this device has, this is how much this device has, and then when it must do like this calculation, so like when you're going to run inference, you know, you're going to run it around this ring basically, and as you need more, it looks like it'll just kind of use all these machines back and forth for the inference there. So 2 weeks later, Kaparthi et al. Will have posted a few optimizations. Yeah. Hopefully. Yeah, I think that's the goal, is for us to get some of that kind of stuff going on here. Jesus, this is beefy. Oh my gosh. Okay. Bro, this is absolutely bonkers. Yeah, this is so beefy. I mean, 832 gigs of RAM. Like, but yeah, I'm curious, like what Alex is going to be the one that's going to be giving us a lot of knowledge here. So I'm pretty sure he's working away right now trying to get this stuff set up. And then at 420, my friends, it's about to go down. It's about to go down so crazy. You know what I mean? Just like that. Super dramatic. Yeah. I mean, look at this. Like, this is going to be our hype. Are y'all ready for this hype? I don't know if I'm ready for this hype yet. Let's go. Yes, that's right. 420 Llama 3.1 is going to be going down. So yeah, I think this is a really awesome. Stay tuned, because I'm going to have the link set up on X, just like the way it is right now. So this is sort of a test stream for me, just kind of, just showing a really basic setup. So right now I'm actually just currently at my house, and as you can kind of see, basically I have my little lights right here. I got the computer set up. And then I have more camera. I have like cameras on standby. I have, my stuff here. So this is like the bag and the cameras and all this other equipment. So that's what we're gonna do. It's about to go down. It's about to be real crazy. So it's gonna be it's gonna be all hype. Actually, it's just gonna be straight up hype. So this is what we do. All right. So I'm really excited. And if you haven't downloaded the models yet, go ahead and do that. Mines are still downloading. I'm downloading all of the things. They'll probably be done in 7 minutes. So this is what it feels like when you get CUDA running with LLMs on Ubuntu. I bet 1000%. Like, imagine feeling like so buff like that. You just come in, just walk into the arena and just say, yo, I got the whole team on my back. I just got everything. Just like, walk in and just crush it. So that's what's up. So yeah, just as a sneak preview of our live stream that's going to be going down. It's going down right now. We're actually trying to download this whole model, all of the things. It's is major heavy right now. So that is what it is. And I will be seeing you folks very, very soon. All right. Thank you very much for tuning in for this quick drop in and just kind of telling you how to get started real quick with downloading this stuff. And I'm going to see you on the other side. All right. 4:20 today, 4:20 Pacific Standard Time. Do not miss this event. This is going to be so fire. All right. I look forward to seeing you soon. Peace out, y'all.